In this video, we are going to discuss how to calculate velocity and acceleration from position function using derivatives. Let's start with question 15. The position of an object as a function of time is given as x equals at cubed plus bt squared plus ct plus t. The constants are a equals 2.10 meter per second cube, b is 1.00 meter per second squared, c equals negative 4.10 meter per second, and d equals 3.00 meter. Part A of the question is asking us, what is the position at t equals 10 seconds? So here in the question, I have already been given the position function, which I can write as x equals at cubed plus bt squared plus ct plus d. And I have the values of the constant a, b, c, and d, which I will substitute in my position function and write that as x equals a is 2.10 t cubed plus b is 1 t squared. C is negative 4.10, so this plus sign here will become minus, plus d, which is 3 meter. In part A, I just need to find position at 10 seconds. And since we already have the position function, I will just substitute time t equals 10 seconds in my function for x here. So let's find position at 10 seconds. X will be equal to 2.10. In place of t, now I will substitute 10. So 10 cube plus 1.0010 squared, negative 4.10 times 10 plus 3. And when you solve this, you get position at 10 seconds as 2162 meter. In part B, we have to determine the velocity of the object as a function of time. Now, if you have position function x and you need to find velocity from this position function v, we take derivative of x to find v. Similarly, if you have velocity function and you need to find acceleration a, again you take derivative of velocity function to find a. So when you start with position function and you need to find velocity function or acceleration function, you have to take derivative of x to reach v and then derivative of v to reach a. So I already have the position function here. I will find velocity function v by taking derivative of x with respect to time. Now, what are the rules of derivative? If you have a quantity which is a function of time t, and for this quantity t is raised to power n, derivative of this function with respect to time t can be written by the rule n times t to the power n minus 1. So you follow 3 steps to calculate this derivative. First, identify the power of t, which is n. Then multiply the term with the power of t. So I multiply with n here. And the third step is to reduce the power of t by 1. Then if you have a constant is a number which is not multiplied with t, which is alone, like the 3 over here. Derivative of a constant with respect to t will always be equal to 0. And then if you have a function which is only t to the power 1, so derivative of just t, dt over dt will be equal to 1. So these are the 3 different considerations I'm going to take while calculating velocity by taking derivative of x. So let's start with our function. V is equal to dx over dt, which you can write as, first we take derivative of the first term over here. This constant, I will keep it as it is, 2.10. We will not take 2.10 as 0 because even though it is a constant, it is still multiplied with t. So any constant which is multiplied with t, we keep it as it is. We do not change that value. Then we take derivative of t cubed. So we follow this step. The power of t is 3. First I multiply with the power, so I will multiply this term with 3. Then I will reduce the power of t by 1. So 3 minus 1 will give me 2. I repeat the same thing with the next term. You write plus, keep the constant as it is, 1.00. You don't need to write that one here, as 1 times any quantity will give you the same quantity. Then look at the power of t, it is 2. First multiply with that power, so I multiply this term with 2. Then reduce the power of t by 1. 2 minus 1 will give me 1. Then again keep the constant as it is, 4.10. Power of t is 1, and we just discussed derivative of dt over dt equals 1. So I will just write this as 1. Then 3 is a constant. The difference between this 3 and 2.10 or negative 4.10 is these numbers over here are multiplied with t. So we do not take them as 0. Whereas 3 here is alone. It's a constant, not multiplied to t, it is alone. And derivative of constant like this is equal to 0. So let's rewrite our velocity function. 3 times 2.10 will give me 6.30 t squared, plus 2 times 1 will give me 2 t minus 4.10. So this is my velocity function v. In part C, we have to calculate the velocity of object at time t equals 10 seconds. So I already found my velocity function in part B. I can calculate the value of velocity by substituting t as 10 seconds in this function. So let's do that. I will write v equals 6.30. In place of t, I will write 10. So 10 squared plus 2 times 10 minus 4.10. And when you solve this, you get the value of velocity at 10 seconds to be equal to 645.9 meter per second, which you can round off to 646 meter per second. In part D, we have to determine the acceleration of the object as a function of time. We already have velocity function from part B, and I can find the acceleration function from this velocity function by taking derivative. So like I said before, if I have velocity and I want to find acceleration, I need to take derivative of this velocity function to find a. So let's do that. I write acceleration a equals dv over dt. So when we take derivative, we keep this constant 6.30 as it is. Power of t is 2, so multiply with that power first, then reduce the power of t by 1. So 2 minus 1 is 1. Plus, keep this constant as it is. Here you have just t. dt over dt is equal to 1. So I write it as 1. Then the final term over here is a constant, and we know derivative of a constant is 0. So I just write plus 0. Solve for this. We get a equals 2 times 6.3 is 12.6 plus 2. So this is my acceleration function a. In part E, we have to calculate the acceleration of the object at t equals 10 seconds. So I already found the acceleration function. In order to find its value, all I will do is substitute the value of t as 10 seconds. So let's do that. We get a equals 12.6 times 10 plus 2. And when you solve this, you get your acceleration as 128 meter per second squared. Question 24. The position of an object is given by the equation x equals 2t cube plus 4t plus 6.25, where x is in meters and t is in seconds. Calculate the acceleration of the object at t equals 1.50 seconds. Again, now we have the position function x, and we need to find acceleration from this position function. So first we will take derivative of x to find velocity function v. And then we will take derivative of this velocity function to find acceleration a. So we have to differentiate this position function twice to reach A. So let's start. I will write my position function x as 2.0t cube plus 4.0t plus 6.25. Then we find velocity function first. So v will be equal to dx over dt. Let's solve. We keep the constant 2 as it is. Power of t is 3. So first multiply with the power. Then reduce the power of t by 1. So 3 minus 1 will be 2 plus 4. This is just t. dt over dt is equal to 1. So I will write 1 here. The final term is a constant. Derivative of a constant is 0. So I get my velocity function as 6t squared plus 4. After you get the velocity function, then you find acceleration function a by taking derivative of this velocity. So do the same step, keep this 6 as it is multiplied with t. Then multiply with the power of t. Power of t is 2. After this, reduce the power of t by 1. 2 minus 1 is 1. Plus, the second term here is a constant. Again, derivative of a constant is 0. So you get your acceleration function as 12t. Once I find the acceleration function, now I can calculate the acceleration of an object at t equals 1.50 seconds by just substituting for t. So we get a as 12 times. In place of t, I will write 1.50. And when you solve this, you get the acceleration as 18 meter per second squared. So this is the acceleration of the object at t equals 1.5 seconds. Question 25. The position of an object as a function of time is given as x equals at cubed plus bt squared plus ct plus d. The constant are a equals 2.10 meter per second cube, b equals 1.00 meter per second squared, c equals negative 4.10 meter per second, and d equals 3 meter. Calculate the acceleration of the object at time t equals 0.50 seconds. So let us first write down our position function x. I write my x to be equal to at cubed plus bt squared plus ct plus d. And then we will substitute the values of the constants given to me. X will be equal to a is 2.10 t cubed, b is 1 t squared, c is negative 4.10 t, and d is just 3. We need to find acceleration at time t equals 0.50 seconds. So we know that in order to find acceleration from position function x, I first need to take derivative of this function to find velocity v. Then we take derivative of velocity to find a. So let's start with finding velocity first. I will write velocity v equals dx over dt. So keep this constant 2.10 as it is. Multiply with the power of t. Power of t is 3. Then reduce the power of t by 1. So 3 minus 1 will give you 2. Plus 1. Again, multiply first with the power of t. Power of t is 2. Then reduce the power of t by 1. So 2 minus 1 will give me 1. Minus 4.10. Derivative of just t is 1. And derivative of constant will be 0. So when you can simplify this, it becomes 6.30 t squared plus 2.00 t minus 4.10. So this is my velocity function. Next, we will find acceleration from this velocity function by writing a equals dv over dt. So we will take the derivative again. Let's start with the first term. You have 6.30. Then multiply first with the power of t, which is 2. Then reduce the power of t by 1. So 2 minus 1 will give me 1, t to the power 1. Plus, keep 2 as it is. Derivative of just t is 1. Then derivative of a constant is 0. So you get your acceleration function a as 12.6 t plus 2. Now I need to find the value of this acceleration at time t equals 0.50 seconds. So here in this acceleration function, I will just substitute for t as 0.50 seconds. So let's do that. A will be equal to 12.6. In place of t, I write 0.50 plus 2. And when you solve this, you get acceleration A as 8.3 meter per second squared. So the only thing you must remember while using derivative to find either velocity or acceleration is that to find velocity, we take derivative of x, and to find acceleration, we take derivative of velocity. And if they have given you the position function x and you need to find acceleration a, like here in this example, you have to differentiate x twice to reach a. First, differentiate to find v, and then take the derivative to find a. And the rules of derivatives are we have to take three things into consideration. First one is derivative for a function with power n. Derivative of this function dtn over dt will be first multiply with the power of t. So I multiply with n. Then reduce the power of t by 1. So n minus 1. Another derivative of any constant c. Constant c like 3 over here or 4.10 over here, which are not multiplied by time t, derivative of any such constant will be 0. And derivative of function just t, where the power of t is 1, dt over dt is equal to 1. So remember these three things while taking derivative to find either velocity or acceleration.